Algebra II, Cram, New York State Algebra II Regents, Common Core, Key Facts, Trigonometric Identities, Formulas, and Equations. Question 7. 3 the cosine of 2x is equivalent to the cosine of x plus 2. To receive this complete Cram session, inbox me at memedicine@gmail.com for pricing and also inquire about other subject areas. Let's delve into the problem. Review question 7. Find all values of x in the interval 0 degrees is less than or equivalent to theta, which is less than 360 degrees, that satisfy the equation 3 the cosine of 2x is equivalent to the cosine of x plus 2. I'll give you a moment to think. Definitely press pause and formulate your solution. All right, hopefully by now you are able to press pause and come up with an answer. And if not, that's totally fine. Let's delve into this together. The equation in the question stem contains both x and 2x. The only trigonometric function in the equation is cosine, so it's best to use the general cosine of 2x or cosine, we'll say 2a formula since we have x in this specific equation, okay? So of the 3 general formula options for the cosine of 2a, or 2x, 2 theta, 2 whatever variable you choose, the one that best suits our purposes in this instance is the cosine of 2a is equivalent to the 2, the cosine squared of a minus 1, okay? So we'll see why in a minute. So basically, let's take a look at our formula so we can move on to plugging things in. So 3 the cosine of 2x is equivalent to the cosine of x plus 2 is what we're given, okay? Now we need to start substituting this into the equation in here where we have our 2x. So this becomes 3 times 2 the cosine squared of x minus 1 is equivalent to the cosine of x plus 2. That then simplifies to this. After you distribute the 3 on the left-hand side, you get 6 cosine squared x minus 3 is equivalent to the cosine x plus 2. Okay, so now let's start to combine terms. So we have written in standard form 6 the cosine squared of x minus cosine of x minus 5 is equivalent to 0. And we like putting things in standard form. And when I say standard form, I mean in the a squared plus bx plus c format, because you can easily factor this type of format, okay? So let's now factor and solve for x. And what we're going to get is 6 cosine x plus 5 times the cosine of x minus 1. And the way you factor to these two things, because the leading coefficient, the a in this is 6, so sometimes people get thrown off when a is not equivalent to 1. First, you look at this number and you ask yourself, what two numbers can you multiply to get negative 5 and add basically to get a negative 1, okay? Well, it's not, so basically you have to do a little bit of plugging and chugging, but you know, this is your starting point. You know you're going to have a 5 and a 1, so it's just up to you to test out this, whether the 5 goes with the 6 or whether the negative 1 goes with the 6. And the general rule is that usually the higher number goes with the a term, okay? Whatever, you can figure that out on your own. So the reason why we're going to factor in this manner is because it makes things really easy. So basically what we're going to do now is separate both terms and let them be equivalent to 0. And by taking this approach, what we're exercising is the zero product property. The zero product property simply states that if A, this is term A, times B, this is term B, is equivalent to 0, then either A, term A, or term B has to be equal to 0, or potentially even both are equivalent to 0, okay? So a product of two factors, this is factor 1, factor 2, is 0 if and only if one or more of the factors are equivalent to 0 themselves, okay? So that's why we can do this. When we set this term, well, the first term equal to 0, we basically subtract 5 from the left-hand side and then divide by 6 on both sides to get negative 5 over 6. And when we set the second term equivalent to 0, we basically add 1 on the left-hand side and add it on the right to get the cosine of x is equivalent to 1. Okay, and none of these values are outside of the range for the cosine values, which is from -1 to 1, so we're good. These are both two valid answers. It's just now we have to actually solve the riddle and answer the question. They're not looking for cosine values or trigonometric values. They're looking for the value of angles, okay? So what we have to do now is take the inverse cosine of both terms, okay? And what we're going to do is temporarily is ignore the negative sign, and we're going to take basically what's called a reference value here. Because we have a negative sign, we know that this thing either is going to be in quadrant 2 or 3, because the numerator, which is the measurement of the hypotenuse, which is going to be represented by a ray in a graph, is always going to be positive because it's not a measure of a coordinate, it's the measure of the length of a ray, okay? So this is like an absolute value or something. It's never going to be negative. The only thing that can contribute the negative to this term is the numerator, or the x value, okay? And here we have the cosine is equivalent, the cosine x is equivalent to 0. Here we don't have to do a reference. We can just take one shot at it and say that one of our values of theta, one of our values of theta is going to be 0, because you should memorize the cosine, sine, tangent values of common terms, like common angle measurements, rather, like 0, 90, and if you memorize that, you would know that the cosine of 0 is equivalent to 1, and so is the cosine of 360. But since the interval does not include 360, we're good here, and we know that our value is going to be 0 only, okay? It's just that we have to figure out what's up with this dude over here. So let's proceed. So basically we take the inverse cosine of 5 over 6, and you have to do this on your handy dandy graphing calculator, and you get the value 33.5573 degrees, okay? Or you take the inverse cosine of 1 and you get that the value is 0 degrees or 360, but we're ignoring the 360 since it's not included in our interval, okay? Now, in the interval from 0 to 360, the cosine is negative in quadrant 2 and also in quadrant 3. And the reason for that is basically what I said before. The cosine consists of this: the x coordinate divided by the r, okay, divided by the length of the hypotenuse. And any length is going to be a positive measure. It can never have like a negative value. I don't know how to express a negative thing that's in existence, that means that thing is dead or it does not exist. So this measurement always has to be positive. So we can determine negativity of a trigonometric function based on the numerator when it comes to sine, cosine. Okay, and here we see that x is going to assume a negative value in quadrant 3 as well as in quadrant 2 because they adjoin on the 180-degree face. Okay, so basically in quadrant 2, our measurements of theta or x is going to be 180 minus the reference angle minus theta ref minus this, or x ref. Okay, so theta ref is 33.5573 degrees, and that's going to be equivalent to 146.4427 degrees, approximately 147 or 146 degrees if you round down, but we'll round up, say 147 degrees, okay? And here we are showing that formula, that theta in quadrant 2 is always going to be the quadrantal, I don't know how to pronounce that correctly, angle bounding the quadrant minus theta reference, which yields theta. Okay, that's what we just did here. So the similar approach goes for quadrant 3, but instead you're adding the reference angle because you're adding to the lower bound of that quadrant. Okay, or you could take 270, the upper bound, and subtract the theta reference from it, but we're just going to stick to using 180 degrees. Okay, so theta equals theta ref, which we have here, plus 180 degrees in quadrant 3, and that angle measurement is 213.5573. Okay, so these are our two answers, approximately 214 degrees and somewhere between 146 and 147 degrees. You decide. Okay. All right. So again, in summary, the solution set is going to be 0 degrees because this worked out neatly. We didn't need to take any other angle into consideration. 146 degrees coming from rounding this value down, as well as 214 degrees coming from rounding this value up. Okay, now let's dig a little further because you could have easily done all of this on your calculator, with minimal effort. Let's see how this is done. Okay, so you can solve this equation graphically, basically using your calculator. And the result will be a detailed graph with scaled axes labeled with the equation and points of intersection and all that. And only the x values of these points that we're going to yield are the solution because that's what we're looking for. We're looking for the value of x. That's what the question specifies, okay? All right, so the first thing that you're going to need to do is to ensure that you're in degree mode, okay? And you can get here by pressing mode, the down key once to take the cursor from hovering over normal to hovering over float. Then you're going to press the down arrow a second time so that the cursor can hover over the radians. And let's say the setting was set on radians. In order to get it off of radians, you would need to press the right key so it can hover over degree, setting your calculator in degree mode. You don't need to press enter to lock degree mode. All you have to do is press second mode in order to quit this window. Okay, so the next important thing you're going to have to do to accommodate the interval that we're using here is set the x values in window. This specific interval with x minimal being 0 degrees and x maximum being equivalent to 360 degrees. And you're also going to set the scale to 90-degree increments for more clarity, okay? So the first thing you're basically going to do is press window. And then you're going to press 0 for x minimum. Okay, press the down arrow once, then type in 360, 360. Press the down arrow again for the x scale, and then you're going to type in 90, 90. Okay, you don't need to press enter to lock in these values. You press second mode to quit the screen. All right, or you didn't even have to do that. You could have went straight to the next thing, but I didn't tell you what the next thing is, although I'm sure some of you already know. So now you're going to do this. You're going to input this equation, but the thing that you're going to do is you're going to separate the two expressions on the left-hand side and the right-hand side of the equal sign. Okay, you're going to input them in as separate expressions. So this is what I mean, okay? So first you're going to type in the left-hand side equation, and you do that by pressing y equals 3, the cosine of basically 2, and then this neat button, which is like xt theta n, okay? And then you're going to close the parentheses, all right? And then you hit enter so you can jump down to the next line and enter your second equation. All right, we're almost done, so bear with me. So you're going to press enter. Now you're going to press the variable button, xt theta n, which is going to give you an n. Actually, before you do that, hit cosine. You press, this is what you do. You press enter, cosine xt theta n. Okay, then you basically are going to close that set of parentheses. You're going to add 2. Then you press enter, okay, to lock in that equation, and then press second mode to exit the screen, okay? Now you want to see your graph. This is the moment of truth that you've been waiting for. So what you're going to press is Zoom 0, which is ZoomFit, and ZoomFit is the best setting in my opinion for simple trigonometric functions. And now what you're going to do is use the CALC feature to find the 3 points of intersection. So this is what it looks like when you press Zoom 0. And automatically you're starting out with your first point of intersection, which is really tricky to calculate because it's all the way in the upper left-hand corner and it may not even be visible. So that's why you have to watch these values here. So let me tell you how to do this whole intersection calculation stuff. You basically press second, trace, and that takes you to the calculation feature, and you choose option 5 to calculate the points of intersection. And then down at the bottom there's going to be a series of on-screen instructions which will require you to go to function 1, function 2, you know, and you gotta know which one is which, okay, so that you don't mess up and make mistakes. But usually it'll automatically set it on the functions for you. And then after you maneuver to function 1, then to function 2, you're going to press enter after you press this series of arrows, okay? And something that you have to note is that the graph shows a 4 solution all the way over here. So you have 1, 2, 3, 4. But our question stem doesn't require the last or fourth solution, which is x is equivalent to 360, so we can ignore it, okay? So basically our solution set again is going to be 0, 146, this point of intersection over here, and approximately 214, this point of intersection right here. Okay. All right. That's it. I know this was very long-winded.